Welcome, and in this video we're going to look at properties of logarithms. So just as we defined a logarithm is really just an exponent needed to produce a particular value, the properties of exponents that we know and love appear in similar fashions with logarithms, and so we're going to get some practice with that. Okay, and so to begin, I just want you to pause the video here and find the common log and the natural log, so log, log, and ln on your calculator, and calculate each of these out. Alright, well hopefully you had some time to do that, and if you did that, you should have noticed that some of these were the same, and then you have a little bit of a moment where you say, oh my god, or oh my god, logarithms, and so why is that? And that's really where we're going to begin here. So properties of logarithms, I affectionately call them the log laws, okay, and so you can actually check out what the dictionary's definition of a logarithm, but properties of a logarithm are going to mirror those of exponents. So we have a sum to product rule. Now we have to apply this effectively. Notice that here we have logarithm base a, and then we have a multiplication inside. Have to have multiplication inside. And when we do, that really is the same as saying we have logarithm of the first factor, x, plus the logarithm of the second factor. So logarithm of a product turns into the sum of logs. Okay. The next one is quotient to difference. So this time we have quotient inside the logarithm, and that leads to a difference between logarithms of the same base. I'll also mention that the bases have to be the same. Okay. So notice quotient inside, division inside, subtraction outside. Okay. And the last one is the power rule. Okay, and so this one extends from the, if we have power to power and exponents, we would multiply the exponents. Well, this is just saying if we have an exponent inside the logarithm, and notice it has to be inside, so parentheses, exponent is inside, then the exponent can come out in front. I'll also mention that the exponent has to be on everything inside the logarithm. So if it's just something like log of 2x squared, that is not equal to 2 log of 2x, because the 2 here, or actually maybe let's change it to a 3 just so we don't get numbers mixed up. The 3 here does not have an exponent of 2 on it, so we cannot do that. If it was something like 3 squared x squared, then yeah, you can pull the 2 out. Okay, so in general, just be mindful of this. So then some examples here. We want to write an equivalent expression for each of the following. Well, in each of these, I want you to try them, and I'm going to have you do the third question as a quiz question, but for the first two, I'll give you a moment here to pause the video and try them on your own. Okay, well, you paused the video, hopefully, and when you did this, you recognize that x is an exponent, meaning that we have the power rule, so then according to the power rule, if we have an exponent on an expression inside of a logarithm, I can pull that exponent out in front as a factor. So, oops, let me write that again. So it'd be x times log of 2, and I'd be done. Okay. Now, this next one, there are many different ways you could write it. Some of you might see, oh, it's like 2x times y. Well, that's true. Okay, and we can say, since we have a product inside, so I have a product inside, that has to go to a sum, right, between logarithms. So it would be natural log of 2x plus natural log of y. And this is okay. I would say that this is not yet fully expanded, because in the 2x, oh, wrong button, in the 2x there is a product left. So you could further expand this out as write it as natural log of 2 plus natural log of x plus natural log of y. Okay? So that's that one. So that uses the power rule, or the first one uses the power rule, second one uses the product rule, and well, the last one you might imagine going to use the quotient rule. Okay, so answer this quiz question next. Alright, and so just to summarize everything here, this I find is a super helpful thing for students to put on formula sheet, whatever. I am not going to give you these on a quiz, exam, etc. You have to know these, okay? So we didn't give you the exponent laws the first time, not going to give you the log laws the second time. So this is just a nice connection. So if when we have beta 0 is equal to 1, the corresponding logarithm property is log base b of 1 is equal to 0. And again, you can use the circle method to write that out if you want, or you can just remember it. Okay. Similarly with an exponent of 1. Okay. And now here, this is where we start to see. So in the exponent law, we had the product to sum property, where we had product between same bases, and we added in the exponent. Well, now in logarithms, it sort of works in reverse. We take logarithm of a product and write that as a sum of logarithms. Okay. Similarly for the quotient of difference and property ones. And this last one is more just the identity that we saw back from section 7.3. So I encourage you to get this down in your notebook and then reference it as needed.